Hi, folks, and thank you for joining us again today with another Brocade Storage Networking video. And today we're going to be talking about cyber resilience and its importance to IT infrastructure. And I am very fortunate to be joined by my good friend and colleague, Truls Mikkelbust, who is the product manager for both our switch and extension products here at Brocade. So thank you for joining me, Truls.
Hey, AJ.
So Truls, as we look at this and we look at the general environment that we deal with and the customers that we deal with, there's a range of things that sort of just get smashed together. It's both the security side of things and then just the reliability side of the environment. And there's actually a pretty broad spectrum of concerns that people should be working through or thinking through, or at least looking to address and making sure that it doesn't impact them. And maybe you could give us a little bit of an overview on that.
Right. So IT organizations today are facing kind of a confluence of multiple different factors that are making it very, very difficult for them to grapple with these challenges. We have what we would think of as a traditional DR. They have to protect against failures from like common things like disasters, like a flood or a fire or hurricane, that kind of thing, an earthquake. Or a failure of a device where you have like a hard drive crash or something like that. But now with all the data breaches that we're seeing, they're really having to protect themselves against cybersecurity attacks. And it's kind of like a new vector that, wasn't as big of an issue before, but is now kind of front and center as kind of one of the big things that IT organizations have to deal with. But it's kind of in this context of you still also have to protect yourself against traditional types of disasters. So you got to kind of deal with both.
So none of your problems went away, but we added some additional concerns for you.
And a significant one, right? We all see the headlines that are coming out, seems like every single day. Not just headlines, we keep getting letters in the mail, right? Every week, sometimes every day, with a new company with yet another security exposure. Often companies that you've never even heard of, but somehow they had your data and now they've leaked out, all your personal information, social security numbers, et cetera. It's a real problem. And those kinds of data leaks are having real reputational impacts on the companies that are responsible. Because we have consumers now going, ooh, can I trust any of these companies now that they've leaked out all of my data?
Yeah, and I think in addition to that, from an operational standpoint, we carry around these little computers pretending to be phones, and I've got access to my banking, to my healthcare, my email, family text messages, and the full gamut of my communication to the world, and we all depend on these things, right? And the interfaces that are here in our daily lives. And so, the uptime of those environments becomes pretty critical. And when we see things, sort of, I'll throw the CrowdStrike incident out there, right? And then the impact that had on Delta Airlines, we can't necessarily be without these for days at a time or 5 days at a time, the way the airline was down. So somebody has to be addressing this, right? I mean, somebody has to be setting standards that speaks to this. Is that a real expectation?
Yeah, I mean, the thing that's happening here is that, we all have higher and higher expectations in terms of availability for more and more types of applications. Like you say, even little things, it doesn't take long before we suddenly expect, it's going to be available 24/7 by 365 from any device, from anywhere in the world, right? And IT organizations often run into situations where they thought of the application as, okay, this is not a big deal. It's not like air traffic control. It's not like the operational control of a nuclear power plant. There's nothing like that where you would sort of think of it as a really, really big deal where it has to be protected, to the nth degree. But what we're finding is, just sort of common, seems like kind of innocuous applications, customers really depend on them. And what happened with the CrowdStrike attack and Delta was, that was not a, traditional sort of mission critical application. Something you wouldn't have thought of it as being a big deal, but that outage caused Delta to be down for about 5 days, right? A huge impact, multi-billion-dollar impact to Delta's business from what had seemed like perhaps a fairly innocuous problem to begin with.
Yeah. So given that it can have that kind of an impact to the environment and how much of our world rides on this infrastructure, what's the current status with government regulation on this? Like what are they doing to keep us safe?
Right. So with all these exposures, governments are reacting. And over the course of the last several years, we've had more and more and more security standards that have emerged that are now being recovered or being required on deals, not just for government customers, but also for, basically any company that is serving, government type customers. These are emerging in kind of all geos. So we see them on each side of the Atlantic and also in other geos. In the US, we had the CNSA 1.0 standard that came out a few years back. We now have CNSA 2.0 that requires, a baseline of security in your environment in terms of how you protect the data. It includes also requirements like the level of encryption that you got to have around data. It's still shocking to see how many times we have data leaks, and then it turns out there was no encryption of the data at all within the environment. And you go, oof, how did they ever get to that? But it happens. But these are now required as part of some of these standards. The thing that we've then seen more recently, we have now in the European Union the DORA standard that goes beyond just sort of base security levels, but now focuses on how fast can you recover from a security exposure type of an event. So it goes beyond just you got to encrypt the data. You also got to be prepared to respond and get back online relatively quickly.
Yeah, I mean, given that we're talking about potentially hospitals and emergency services as well, right? It makes sense that there would be a requirement for recovery. So you mentioned encryption, and I know that we talk quite a bit about the fact that we have 256-bit AES encryption on our environment. Maybe you could talk us through why you guys spent the time and effort to build that into the hardware, for example, on our extension products.
Right. So there's been a lot of progress unfortunately, by hackers in terms of breaking encryption. And so, back in the day, we had encryption that was like, 40 bits, 56 bits, that was sort of considered strong, a long time ago. But these days, particularly with the advent of quantum computers, we're now seeing that even encryption algorithms that were recently considered pretty robust are now considered vulnerable. If you look at the CNSA 2.0 standard, it requires much stronger encryption than what has previously been required. AES 256 is one of the security algorithms, encryption algorithms, that's still considered quantum safe for all levels of classification for the US government, including for top secret data. So that is a standard that holds today and that is required as part of the CNSA 2.0 standard. Unfortunately, there are vendors out there that did not invest in significant encryption. So you have solutions that, gear that's on the market today where, yeah, it's AES, but it's AES 128 perhaps. Well, that's not strong enough to be secure against quantum computer type attack. But the good news here is that all encryption that we offer, both in our core SAN switching solutions, as well as in our distance replication solutions, is AES 256, strong enough to meet the standards of CNSA 2.0 and to resist a quantum attack.
So you were talking as well about the DORA standard and the need for recovery, and obviously, well, or at least obviously to me, one of the things you need in order to recover is you need the data that belong to the application, right? And so there's this concept of recovery point objectives and recovery time objectives, right? And recovery point objectives sort of being how much data can you lose and you're still okay, and recovery time objectives being sort of well, how long can you be offline and you're still okay, right? And perhaps you could give us a little bit of a view into how people would look at those things.
Yeah, AJ, let me just kind of net this out. RPO and RTO are concepts that have been around for decades now, right, in traditional DR. And the way to kind of think about it is the recovery point objective that defines how much data you can afford to lose. And we have certain kinds of applications where the sensitivity to loss of data is very, very high. An example is a banking type transaction. If you just withdrew or just deposited a whole lot of money into your bank, you don't want to have a situation where there's a disk crash and suddenly that transaction was lost, and where the money you just deposited just suddenly went away. So that's a case where the recovery point objective would be 0. The bank would always be concerned. They would never, ever, ever want to lose even the very last transaction that went in before, disaster struck. The other one is recovery time objective, and that's all around how fast can you recover. So the bank might say, for those ATM transactions, I don't want to lose any data. And it wouldn't be good if the ATM was down for a while, but at least it's a different order of problem than losing a transaction. But there are other kinds of solutions that take an access solution for a building. More and more buildings now, just about every building has key cards, right, to access and get through the door. It's not traditional keys anymore. And the systems that run that access control into the building, they have a huge amount of sensitivity to the uptime. So they might not be as sensitive to the recovery point. Let's say that the last change that you made was that you just added, there's a new employee that just started, so we just added them into the access system. Well, if that is lost, yeah, no big deal. I might have to go in and add that user back in. Maybe I got to add 10 users back in. It's not a huge problem. But if the system goes down and you can't get it back up and running again, let's say it takes a week and you go a week without access to your building, well, that's a huge problem. Yep. And so that's a type of application where the sensitivity to the recovery time is the #1 thing for that application. And in fact, we had a couple of really high profile failures recently where the systems crashed, and one of the systems that crashed was the access to the building. And they needed to get into the building to get the systems back up and running again. But anyway,
chicken and egg
cases where the IT team couldn't even get into the building because they lost the access control system as part of everything else.
Yeah. So, clearly one of the things that you have to be able to do if you're going to survive, tornado, a hurricane, a broad scale power outage, massive heat wave, ice storm, whatever it might be, is you need multiple copies of the data set, secure copies of the data set, timely copies of the data set, right? And so, what's Brocade doing to help support that environment?
Right. So IT organizations have to protect themselves against all of those disaster type scenarios that we just talked about. Could be a cybersecurity attack, a ransomware type attack, or it could be a traditional failure like a fire, hurricane, or a hardware failure. And so we have this concept of immutable copies, where more and more arrays now can basically store a snapshot of data and store it in a form where the data cannot be rewritten. So a cyber criminal breaks in, they try to encrypt the data to do a ransomware attack. It's not possible because the array won't allow the data to be overwritten. Well, but to protect yourself against all these scenarios, you also need to be able to, you can't just make a copy and have the copy be local, because if you then have a fire, well, then you're losing kind of everything. So you need to get your data far enough away that it's going to be protected against traditional types of disasters. And usually a metro area is not enough distance, right? If you have, let's say, an earthquake or really big wildfire or like a hurricane, that'll often affect an entire metro area. So typically, the minimum distance that you need to go for that replication is out of state, and sometimes from one side of the continent to the other, or intercontinental, to make sure that you've gone far enough that you're not going to be affected by whatever disaster strikes that original site. And the challenge that you have there is the second you go far, you have latency over that connection, you have packet loss over that connection, and that connection is often kind of expensive, for longer distance connections. And so then you have the challenge of latency and packet loss of really corrosive to replication performance. So trying to keep up with this, you want to make sure that you have a replica that is as current as possible, so that in the event of a cybersecurity strike, you can go back to a fairly recent copy, assuming that it's clean. That's another point. But you want to keep up with the I/O that's coming in. but it's difficult to achieve great replication performance. The good news here is that Brocade has solutions like our Brocade 7850 replication or extension switch that provide fantastic replication performance over long distance connections, full intercontinental distances, even when there is latency and packet loss over that connection. That allows customers to replicate at near local levels of performance, often in the range of 30 to 50 times the performance that a storage array can do natively on its own. And it helps get the data securely to the second site. And by the way, that's all done with strong encryption done in hardware with no performance impact. So the data stays secure over that long connection where you're definitely not going to have full physical security over that connection. You want to protect yourself against anybody tapping in to the replication traffic over that distance.
Agreed. Yeah. So I think one of the things that comes into this conversation is the discussion of Fibre channel versus other technologies or other topologies, and the concept that Fibre channel is inherently more secure. I mean, among other things, we don't have the proliferation of massive numbers, billions upon billions of devices that are making connections to the application servers in the environment across our networks, right? And so, that's one element of it. But I think, again, just the difference in the architecture for Fibre channel, the fact that we effectively create a 1-to-1 ratio, not the shared environment that you see, in other topologies, where once a server gets hacked, and as Michelle reminds us from time to time, the FBI said it's a when, not if. When you get hacked, not if you're going to get hacked. It's just a matter of time. That the exposure from that entry point is very different for us than it is for other technologies.
Yeah, so the big deal there is that you're not just running IP traffic, where if a server, let's say, does get hacked, then immediately you have kind of the entire network completely exposed. With Fibre channel storage, the scope is limited to what that one server has access to. So in a typical SAN, where they've got zoning, they've got limited access, where the server that might have been exposed really only has access to its own storage. And so the scope is limited to, okay, you can start encrypting the data that's seen locally, but it's not going to have the impact on the other servers that might be in that same storage networking environment. It's inherently more secure from an architectural perspective. The other thing that we've done is we've invested heavily in what we call our zero trust architecture. So we've seen some pretty ugly examples where cyber criminals have managed to make their way into firmware updates and sort of ride their way into an IT organization, through a firmware update. Or there's been cases where people have modified the actual hardware. And in Brocade's Gen 7 products, we do in-depth validation of both the hardware and the software. So when we boot up, we make sure that the actual hardware that we're running on is unchanged relative to what we produced at the factory, that there couldn't have been an additional chip or something like that inserted on the motherboard. And we validate that the firmware that's running on there is the original firmware that we created and signed, at our factory, and that it hasn't been modified either wittingly or unwittingly by a cyber criminal, or in some cases we've seen exposures where somebody was in there playing around with the firmware to try to enable something that perhaps wasn't supported out of the gate, but they've created a security hole through the modifications that they've made. We make sure that both the hardware is original and the firmware is original as it came from Brocade.
So it sounds like between the software aspect of it and the hardware aspect of it, both on our switches and on the extension products, we've really locked down that environment and provided a very secure structure for it.
It's all about making sure that customers know that when you're running Brocade infrastructure, you have gear that you can rely on. It's inherently more secure from an architectural perspective, but we've also taken all the steps to make sure that the hardware and the software is really locked down and can be trusted.
I can't help but throw in the observation that Fibre Channel is the place you put the data and the applications you actually care about, right?
Right.
If you really care about it, you put them on Fibre Channel. If it's okay enough, you can use other technologies, and that works too. So I want to thank you very much for being here today and helping me explain to our audience, and thank you again to the audience as well for joining us today. It was certainly an enlightening conversation, and if you'd like to know more, you're going to see a list of resources at the end of this video that will walk you through that. And again, Truls, I just want to say thank you very much. It was a real fun time.